Hi, I'm Mr. Fit. Do you know how pressure affects the rate of reaction? Today we are going to discuss how pressure affects the rate of reaction. But wait! Before we start explaining anything, we first have to understand what is the collision theory. Chapter 1, Collision Theory. The collision theory states that particles need to collide with enough energy to react with each other, and this energy is called activation energy. If the energy is too low, no reaction occurs, and the particles just bounce off each other. When thinking about a reaction involving many particles, the reaction rate mainly depends on two things at any given time. Higher energy levels in the particles allow for more energy transfer during collisions, increasing the chance of reaching the activation energy. The more often particles collide, the more they interact. However, not all collisions result in a reaction. This is because the particles might not have enough energy to reach the activation energy, which can stop them from reacting effectively. More collisions mean more interactions because they happen more frequently. To see how collision theory affects reaction rates when pressure changes, we need to think about how the energy of the particles changes. Now, let's talk about the rate of reactions. What is the rate of reaction? Before we continue, let's invite Mr. John to explain about rate of reaction.
Hey, I'm John. I'm going to explain about rate of reaction. The rate of reaction refers to the speed at which a chemical reaction occurs, as measured by observing the change of products and reactants. But wait! Temperature, surface area, the presence of a catalyst, and the concentration of a reactant are factors that influence the rate of reaction. Did you know that there's another factor that isn't commonly discussed? Can you guess what is it? It's gas pressure. Did you know that understanding the rate of reaction in both scientific and real-world applications are important? This is because by finding out how fast the product is made, and what causes reactions to slow down, you can find methods to improve it. Examples of this is elephant toothpaste depends on the concentration of hydrogen peroxide and the amount of catalyst used in it.
Since we were on the topic of gas pressure, let's talk about it.
The definition of gas pressure is the amount of force exerted by gas particles in a container. Pressure and the rate of reaction are directly proportional. Therefore, if pressure increases, so does the rate of reaction. Higher pressure increases the frequency and effectiveness of collisions between reactant molecules, speeding up the reaction. Lower pressure reduces collision frequency, slowing the reaction rate. But hey, what is the scientific explanation behind this influence? You may ask. Collision theory states that reactions occur when particles collide with enough energy and the correct adjustment. Higher gas pressure increases collision frequency, boosting reaction rates. Increasing pressure in a reaction involving gases leads to more frequent and energetic collisions. This raises the number of effective collisions, where reactants have the necessary energy to overcome the activation energy barrier, speeding up the reaction rate. Vice versa, reducing pressure lowers collision frequency, slowing down the reaction. Here is an example of pressure in real-life situation. Carbon dioxide dissolves in oceans. Pressure makes this chemical reaction possible. The product of the reaction between the carbon dioxide and water is carbonic acid. It makes the ocean even more acidic. In summary, carbonic acid forms when carbon dioxide mixes with water, a process that happens under pressure. When carbon dioxide dissolves in the ocean, it makes the water more acidic. Since both concentration and pressure depend on the number of particles in a given space, they are often considered the same thing. An increase in either of these factors means there will be more particles in a given space, which raises the chances of them colliding. This speeds up the reaction rate.